Good afternoon, everyone. Can you hear me?
Yes, sir.
Yes, sir.
Okay, good. We have 5 students today. Do we have any more? Oh, I'm not sure how many of you are doing it. Doing the special degree, I think this might be the correct number. So we shall start. So welcome to the Advanced Electronic course. I'm Dr. Gayan. I will be the lecturer for your course. We will be having this lecture every Tuesday from 1 p.m. to 4 p.m. So today at the beginning, I will give you some brief introduction about what we are going to cover. I guess you can see my shared screen. By the way, if you have any questions, you can ask at any time, okay? One has a power cut. Okay, then I will record this and upload it to the upload and share it to you. That even a person who could not join the lecture will be able to learn the content. This particular course, known as Advanced Electronics, I will try to cover it in a slightly different way. I'm sure you have already completed the electronics course at level 4. In a way, this is an extension of that course. But on the other hand, the delivery and the objective of this course is quite different. In the level 4 course, the main objective was to introduce you to the world of electronics. Hence, it was more detailed. There were more examples. There were a lot of theories. Most of the focus was on learning theories, memorizing certain formulas and definitions, and doing some standard calculations. You might have heard in teaching and learning, there is a pyramid. The lowest level of learning will be about memorizing things and things like that. A little bit higher, you will have things like calculations. At the topmost echelon, you will have things like creativity, designing, analyzing, things like that. Level 4 mainly focused on that lower parts of that pyramid. You were not asked to design circuits or to analyze circuits. What you were asked to do were mainly calculations based on already familiar circuits. However, in level 6, now you have advanced enough to start thinking about that upper level content. That doesn't mean it will be hard. It only means the things will be different. So the objective of this course is to provide with you knowledge so you can look at a circuit and understand how it works. And also, most importantly, to design a circuit of your own. When I say design, that's not limited to just finding part numbers. What I mean is, let there be a client who needs certain requirements, a certain system to be built. He says, I want these functionalities. Then you should be able to design a system by yourself. The main difference is, when it comes to creativity, there's no correct or incorrect answer. Of course, there can be completely incorrect answers, but there can be more than one correct answer. Or in certain conditions, there can be no correct answer. So you have the freedom to design the circuits. So when you have that kind of objective, the teaching method will vary. Because the tools that is required to do that is different to what you learn at level 4. So let me very briefly go through the content we are trying to cover. First, we have the, I hope you can see what I'm drawing. We have the overview. That is what I'm doing right now. I'm giving you an overview of this particular course, telling you what the objectives, what we are going to cover, and how many lectures and things like that. Then I'm going to give you a different type of, how can I say it, a different type of tool. You can think of them like building blocks or Lego sets. Now, when you were little, you must have been playing with Legos. Anyone who had played with Legos? Lego in Sri Lanka or building blocks? What about you? Did you play with Legos when you were little?
Yeah.
Yeah, okay. We have Marsha. What about you?
Yes, sir. I did.
Yeah, okay. I think others has already played as well. But the idea is you have a certain block where you can fix into another block. Together, they give you a certain shape or function or something. Electronics can be learned in that manner as well. You have certain blocks, circuit blocks. Each circuit block does something independently, something unique. Maybe you have a sensor block that sends light. Or maybe you have another sensor block that sends temperature. You can have another block that generates sound. You can have a block that compares two signals. So by combining these blocks, you will be able to design a circuit. Now, of course, it is not straight, but it's kind of straightforward, but not straightforward as just joining the blocks. You have to know the blocks and also their limitations. And if there are any concerns when you're connecting two blocks. However, that kind of view will be very useful because you have very abstract view. If somebody came and said, okay, I want to design a circuit such that, let's say, when the power cut is there, current is gone, and when somebody open a window in my home, I should get a SMS alert. Now, if you try to think it in the lower level, in the level of transistors, diodes, and ICs, it will be quite tedious. You won't have any idea how this overall project should be worked. But if you think in the concept of blocks, in abstract view, you will find it is easy. Definitely, you need two sensor blocks, one to determine whether the power is there, and another sensor block to check whether the window is open or not. Then you need another block to send the SMS. Once you separate them, it's easy for you to understand what each block should be doing. For example, if you want to detect the window is open or not, then you can think of different sensors, how each sensor can be utilized. What are the advantages and disadvantages? So the next thing we are going to learn about is these blocks. Now remember, this blocks is not a standard electronic term. I just put it there for ease of understanding it. Now they come in different shapes and types. We have mainly three different types. We have the inputs, which basically means sensor blocks, which look at the nature or the environment and get some electrical signal into it. Then you have the outputs, right? Then you have the outputs. Now these are the things that basically convert your signal into something tangible, right? We sometimes call this actuators, like motors, lights, and things like that. Actuators. And most of the time we need to have a processing block as well. You can't directly connect input and output except in a very simple scenario. Certain times you need to have a time delay, certain times you need to have a logic. For example, in our previous scenario, you need to check two conditions. So it's you have a logical connection. So you need to have processing unit as well. Sometimes you need to pre-process your input to filter out certain noises and things like that. So you have processing blocks. Now the processing blocks again will fall into two main categories. We have the analog and the digital. In case we want to check both conditions, whether the power is there and the window is open, most familiar way would be to use a digital gate circuit. So you have the digital domain. On the other hand, you might want to filter out certain noise or look at certain amplifications. Then you might want to go with analog electronics like filters and things like that. There is another category which is in between, which sole purpose is to convert analog into digital signals and digital into analog. We call them as ADCs and DACs. So their purpose is to convert between these two different worlds. We will look at what this analog and digital and everything as we move on. Right. So in theory, this should be sufficient. But in practice, that is not sufficient because I want you to really do something. So that means you have to know how each these blocks are working, and also there are some components that you might need to learn. These are discrete components. That means, okay, we'll come to that a little bit later. Now, let's say you have some kind of requirement. You are asked to design a circuit. So you make some design and you have some overall idea which blocks to use. But before actually building the circuit, it would be better if you can test it. Actually go into the shop and buying these components and soldering, and only at the end finding that it is not working. It's not a good way. Of course, you can do it theoretically, but as the circuit get more and more complex, analyzing them will become harder and harder. Even a very simple circuit like a LC circuit will require differential equations. So if you have a very complicated one, it would become hard. That's where the computers come in. They are very good at mathematics, so we can let the computer do that testing. So once you design the circuit, you need to test it or try out your different ideas. So that's where the circuit simulations come into play. You can very easily build a circuit in your computer and then see how it behaves. You can measure different parameters. You can change values of components. You can find new components. Once you're satisfied, then you are able to build it. So circuit simulation is another one that we are going to cover. Next, we are going to actually build a circuit. So there you have to learn about different discrete components. In theory, you might say, okay, this is a 220 ohm resistor. But in reality, you won't get a resistor like this. What you physically get is something like this. And you have certain bands. Then you have to know how to find the value. In addition, you have certain other parameters like the wattage. Should I use a 1 watt resistor, 2 watt resistor? What type of resistors available? Where they are used? Now, those things will not come into circuit simulation or blocks. We will discuss these things under discrete components. So you will know when you are actually building the circuit, what type of components to use and why you are using it. Last but not least, we will learn about the measuring equipment. Although I say measuring, it can be either debugging things as well. Once you build a circuit, there's no guarantee that it will work forever, or it will work at the very beginning, at the very first try. At that time, so you have to find out why it is not working, whether it is a dry joint, whether a certain component had failed, whether a certain PCB track had broken. Then for that, we need some kind of device. If you're a person, when you go to meet a doctor to get treatment for a certain illness, doctor can use different tools. He can use the stethoscope, maybe ECG, EEG, blood reports, things like that. These are tools. Similarly, when a circuit gets ill or dead, you have to use tool to find out what's wrong with it. Things like multimeters, oscilloscopes, logic probes. These are some of the tools that we can utilize. So you need to know about these tools as well. So these are the main components I plan to teach you in this one. There's one extra component that I'm not planning but letting you learn. That is a small mini project. Years ago, we had students building them physically, but given the current situation in the country, I'm not sure whether we will be able to ask you to actually build it. We will see. At least we can start it at the simulation level. So once you start simulating, and if the things are okay, then we might go ahead and ask you to actually build it. So that is the overview of our course. However, we will not cover it in this particular order. We will not have the mini project at the very end, because then you will not have enough time. And things like circuit simulation, it's better to learn early, so you can see certain things like how the different blocks are working. So it will not done in this particular order, but rather we will have about 3 main components running in parallel. For example, I might, in a particular day, in a particular session, I might teach you a little bit about one type of a particular sensor. And I might teach you one component of analog electronics, and maybe a little bit about either a machining equipment or a circuit simulation. So that way it becomes less boring, and you get a feeling of how each components are put together. Right? So it's not like we are going to finish all the sensors and then finish all the actuators and then go into analog and then go into digital. It's not like that. It's basically running in parallel. So if you are feeling confused, keep in mind that our main objective here is this one. We learn about different types of blocks. By learning about these blocks, you will be able to design and circuit. The rest of these tools are there to help you design it, implement it, and test it. So the final objective will be the mini project. So we will give you some specifications, or we can ask you to come up with a project idea yourself. Then you have to go through this phase and design your own circuit. Right? That's the overall view. Are there any questions about this content? Now remember, this is very open session, so you can ask any question at any time you want. Anything you want to ask, Kosha? Okay, no questions. Give me 2 seconds, and I will join you right after this one. Now I will start with a question that I had asked you when you were at level 4. Let's see how many of you remember it. What is the difference between an electrical device and an electronic device? What is the difference between an electrical device and an electronic device? කවුද ඉන්නේ දැන් ලෙක්චර් එකේ කියන බලන්න උත්තරය මොකද්ද electrical circuit එකක electrical device එකකයි electronic device එකකයි main වෙනස මොකද්ද මූලික වෙනස මොකක්ද
electronic devices mainly depend on the flow of electrons and also digital circuits, and electrical devices mainly depend on the electrical power and also analog circuits.
You are close to a certain extent but not exact. We'll ask someone else. Prasad, what about you?
So idea එකක් නම් ඇත්තටම නෑ.
වැඩියක් නෑ. අපි අහලා බලමු පැතුම්.
Electrical devices convert electrical energy into mechanical energy. Electronic devices work on electrical energy. And do it simple.
ඊට වඩා ටිකක් කිට්ටුයි. නමුත් හරියටම ආවේ නෑ. Right, we'll do something like this. We'll write some examples for these two types. Then you will get an idea. Give me some example for electrical devices. Or rather, I will give them, you have to put them into categories. Mobile phone. Smartphone. Is it an electrical device or is it an electronic device?
Electronic. Put it like this. So mobile phone is electronic. Okay. Everyone agrees? Are there any disagreements?
It can be in between also.
In between?
Yeah.
Okay, it's somewhere in here as well. Okay. Ceiling fan. You know the fan, ceiling fan.
Electric.
I can hear the word electric, but after that, I don't know. You have to say electrical or electronic.
Electrical.
A or B. Otherwise, you will drop after this point. Electrical, category A. You can type it in the chat, A or B, okay? That will be better. So, fan. Which type should be fan? Okay. A, right. Computer. Computer. Okay, computer is in the middle. Okay. Water heater. Do you call water heater electronic device or electrical device?
Electrical.
Let's say electrical kettle. That will be easier. Kettle.
Electrical.
Kettle goes as electrical device. What else can we have? Okay. I think this should be sufficient. So what you see in this category is mainly the main objective is the energy conversion. That means electric energy into some other form. It can be heat, kettle will convert it to heat, or it can be kinetic energy, the motion, like in a mobile fan, or it can be a light. So energy conversion is the main objective. The keyword is objective. What we expect from this device. But if you look at something like a mobile phone, you can have a torch in the mobile phone, but the main purpose of the mobile phone is not to use it as a torch, but either to browse the internet or to call to someone or have a WhatsApp message, things like that. So when you're having a WhatsApp message, your main intention is to tell the other person something, right? Tell the other person something. So it basically works with information and data. To work with information and data, you might need energy. That comes in the form of electrical energy, electricity. However, the main objective is not the conversion, but work with information or data. Work with in the sense it can be sharing, processing, storing, retrieving, those kind of things. For example, if you look at a TV, what is the main purpose of a TV? Is it to provide you with information or is it to provide you with an energy conversion device?
Information and data.
Sorry?
TV information and data. I think so.
Yes. It doesn't have to be you think so, because that's the purpose, right? When you are running out of light, you don't use a TV as a light source, right? If you want to get the light, you will use a light bulb, not a TV. You will use a TV either to watch the news or watch a movie, something like that. So it falls under electronic category. So that's the main difference, electrical and electronic. So our focus will be on electronic devices. So that means we will be looking at data and information. There are two different ways to represent data and information. One is using continuous signals. Other one is using discrete signals. In the signals, in the sense, I am meaning voltage levels. For example, there might be a sensor. That sensor might be outputting a voltage, and this might be the time. So this sensor might have some voltage fluctuations like this. I don't know, maybe the temperature. This is a temperature sensor or something. So you can see in this case, you have a range. This is the upper range, this is the lower range. And within that range, our sensor fluctuates its voltage continuously. It can take any value between this range, within this range. Such a circuit that uses continuous voltage levels to represent information is known as an analog circuit. That is an analog circuit. There can be other circuits that represent data in discrete levels. For example, whether a paper is jammed or not. Then either your sensor says it's jammed or your sensor says it's not jammed. You don't get any discrete, any intermediate values, either switch is on or switch is off. You can have more than two levels, but usually for the most practical cases, we have this kind of binary level representation, binary logic. This is known as a digital information or digital information. A circuit that works with digital information is known as a digital circuit. Circuit that use this kind of continuous signal is known as an analog circuit. And there is a way to convert analog into digital and digital into analog. These are called ADC and DACs. Right. So that's some basics about what we are going to go through. So that's why we have this analog and digital and hybrid in the middle. Right. Now I'm going to draw a very generic block diagram. What we have is a sensor. It can detect certain things from the environment. I don't know, whatever things that you can detect. Temperature, heat or light or whatever. Then the signal from the sensor will go to the processor. After that, you have the actuator. Which outputs something. So these are these main types of blocks that we are going to discuss. We are going to look at different sensors. We are going to look at different actuators. We are also going to look at different processing units. That's what this course is mainly about, and how to connect them. We shall start with a very simple sensor. Now, sensor's purpose is to detect input. It can be from the environment. For example, you can have a temperature sensor in your car engine. So when it is overheated, you will get a light blinking, saying engine is overheated. Then you have a temperature sensor. There it takes it from some environmental value. Sometimes sensor takes input from a person. For example, if you look at a fingerprint scanner, now that's biological. Now when the person put the finger, its biometrics is scanned. So that's input come from a person. Sometimes it comes in a very simple form like switches. It comes in a very simple form like switch. Since this is the first lecture, we will starting with this very simple sensor, which is the switch. There are different types of switches. We will start discussing about switches today. Before going that, yesterday I put an email asking you where, if possible, to install the Proteus. How many of you were able to install the Proteus?
So මේ Proteus download කරගත්ත සර් මේ power cut එකේ හින්දා පොඩ්ඩක් මේ
හරි කමක් නැහැ. ඒක තමයි මම වෙන පැත්තන සාමාන්‍ය Proteus එකෙන් තමයි පටන් ගන්නේ. මට හිතුණා මම දාපු වෙලාව ටිකක් පරක්කු වැඩි කියලා. මම ගිය සතියේ නෙමෙයිනේ දැන් මේකෙන් හින්දා අපි Proteus එක ඊළඟ සතියේ කරමු. අනිත් එකත් මම හිතනවා Proteus තියෙනවා ඇති කියලා. ඉන්ස්ටෝල් කරන්න බැරි වෙච්ච කවුරුවත් ඉන්නවද? බැරි නම් ටෙක්නිකල් ප්‍රශ්න මොන හරි තියෙන Okay, we were discussing about switches. Now, where do you find switches? Switches කොහෙද තියෙන සාමාන්‍යයෙන්? කියන්න බලන්න මතක් වෙන තැන. Electrical switches කොහෙද තියෙන්නේ? මේ level 6 special ළමයි නේද? ඔය ඔහොම බෑ. switch එකක් තියෙන තැනක් දැනගන්න ඕනේ කොහෙද ගෙදර කොහෙද switches තියෙන්නේ? Pathum, where do you have switches in your home? Pathum, are you there?
Yes, sir.
ගෙදර කොහෙද switch තියෙන්නේ?
The wall.
උදාහරණයක් දෙන්න.
The wall.
ඔය බිත්තියේ තමයි නම් මං අහන්නේ. බිමයි කරන්නේ නෑනේ. මොනවට කනෙක්ට් කළාද? මොකක්ද ඒකේ purpose එක?
Switching on and off. Light,
on and off කර මොනවද?
light bulb.
light bulb, light switch එකක් තියෙනවා. light bulb on and off කරන. අපි හමු තව එකක් ප්‍රසාද් තියෙන. ප්‍රසාද් තව කොහෙද switches වල දැකලා තියෙන්නේ? electrical switches.
සර් මේ ඉලෙක්ට්‍රිකල් ඉලෙක්ට්‍රොනික සාමාන්‍යයෙන් ඕන ඩිවයිස් එක තියෙනවා නේද?
එකක් කියන්නකෝ එකක්. එක උදාහරණයක්.
switches
සමහරට buttons කියලා විදිහට වචන වෙනස් වෙන්නත් පුළුවන්. සමහර පාවිච්චි කරනවා button කියන වචනේ.
switches තියෙනවා සර් දැන් මේ කෙටල් එක ගත්තත් එතකොට ඒ වලත් තියෙනවා සර්
ඒවත් තියෙනවනේ light
ෆෑන් එකේ on off කරන්න
fan එකේ තියෙනවා. kettle එකේ තියෙනවා. මොනවද?
Washing machines.
washing
buttons.
machine. ඔව් ඒක ටිකක් බටන් එක තමයි පාවිච්චි කරන්නේ. මගේ අකුරු නම් කැතයි මේ මෙහෙම ස්ක්‍රීන් එකේ මට ටිකක් අමාරුයි. ස්ක්‍රීන් එක ලිව්ව නැත්නම් ඉතින් කැතයි කමන්නේ කරන්න දෙයක් නැහැ. ඒක බටන්ස් කියලා තමයි යන්නේ. තව කොහෙද අපි අහමු කාගෙන්ද අහමු නැති කෙනෙක් ඉන්නේ තව? මේ සාමද මට නම හොයාගන්න බැහැ. සාමා. කියන්න බෑ නේද?
So computers, TVs, remote controls. Yeah.
Remote. So I think... Right. Now, if we look at these switches, you can see there are different types. Now, if you look at a light bulb control switch, most of the time you only have the on and off, like 0 and 1. If you look at a fan, you might have an on-off switch, or you might have a regulator. In the kettle is a special case. How do you use a kettle? You first pour the water into kettle and then this is the kettle. Switch is usually here. kettle එකේ මොකද කරන්නේ? switch එක අපි දානවද නැද්ද? කොහොමද සාමාන්‍ය kettle එක පාවිච්චි කරන්නේ electric kettle එක? electric kettle එකක් ගෙදර නැද්ද?
වතුර දාලා ස්විච් එක on කරනවා.
වතුර දාලා switch එක on කරනවා. ඊට පස්සේ අපි off කරනවද?
ඔටෝ ඔෆ් වෙනවා.
ඒක auto off වෙනවා. මේ switch එක තව විදිහක switch එකක්. මේක auto off වෙනවා. washing machine එකේ මොනවද තියෙන්නේ? මේ වගේ switches ද තියෙන්නේ. අපි light bulb වගේ switches ද තියෙන්නේ.
ඒක වෙන ඔප්ෂන්
ඒ ටිකක් තියෙන push button type නේ. මේගේ ටොක් ටොක් ගාලා දෙපැත්තට දාන්නේ නෙමෙයි ඔබලා අතාරින්න තියෙන්නේ. remote ticket, most of the time remotes also will have the same type, right? So you can say, although we say switches, there are so many varieties of switches, and they all have their own advantages and disadvantages, different use cases. So we'll start with something very simple. First type we have is called the toggle switch. What we have is the toggle switch. The symbol is like this. This is like an on-off switch that you find in most of the devices. You have this kind of on-off switch. You have two connectors. Depending on that, you can either switch it on or off. Then we have push buttons. Have you seen push button? Push button දැකලා තියෙනවද? මෙන්න මේ වගේ එකක්. push button දැකලා තියෙන අය කවුද කියලා බලන්න.
Yes.
එක්කෙනෙක් දැකලා තියෙනවා නේද?
දැකලා තියෙනවා.
දැකලා තියෙනව නේද? Now push buttons come in two different varieties. Now we found an image. So this is what the push button looks like. One is called, go the line in this direction, push to on. Okay. Other type is called push to off. So what does that mean? Push to on means its symbol goes like this. When you push the button, the electrical connection is made. Sometimes you have, when you push it down, the connection is made. When you say push to off, by default you have the connection, but when you push it down, connection is broken. Push to on එකේදී සාමාන්‍ය default එක තියෙන off state එක එබුවම on එක. Push to off එකේදී default එක තියෙන්නේ on එකේ state එකේ එබුවට පස්සේ ඒක off වෙනවා. Right? And then we have, there are so many different types, but then we have selector switches. Selector switches means you have a switch that can be connected to different outputs. You can connect it to different outputs. Let me show you an example. There are different types of selector switches. Now, this one is different type of selector switch. For example, in car ignition, you have different places where you can put the ignition key and select what the operation is. But there's another type as well, something like this. We have this type of switches as well. Now these switches come in different connections. We have SPDT. So this one stands for single pole double throw. That means you have a single pole that can be connected to two of the possible output options, either to A or to B. Single pole double throw. Or you can have DPDT. That stands for double flow, double throw. Something like this. And the important fact is both of these switches work together. So when you put it to the top selector, both holes will connect to the top connector. When you put it to the bottom connector, both of these will connect it to the bottom connector. So you have SPDT, DPDT. You can have SPST as well. Single pole, single throw. That will basically be like a toggle switch like this. So these are some of the common switches that people use to control different devices. Now I'm going to give you a question. Right? Otherwise, I am the only one who's talking. Here's the question. This is a very famous question. Let's say you have a staircase. And there's a light bulb in the middle. Let's do it in some other color. There's a light bulb in the middle. Now a person wants to have a switch here, bottom of the stairs, and a switch here at the top of the stairs. He wanted to make sure this bulb can be on and off at either of these switches. What do I mean by that? Let's say you're coming from here. It's dark. So you switch on this bulb from this switch. And then when you look up, then after you went up, you switch off this bulb using this switch. Let's say another person comes, he again switch on it from here and switch it off from here. But then you want to leave back. Then you switch on the bulb from the top, walk down and switch it off from this switch at the bottom of the stairs. Right? Now I want you to design a circuit for this particular scenario. You don't have to draw the stairs. Let's say you have a bulb and you have the battery. You can use any of these types of switches. You can use SPDT or DPDT or toggle switch or push button, or whatever you like, but no other electrical component. You can't use latches, flip-flops, counters. Those are not allowed. Using only switches, I want you to design this particular circuit. Okay. How many of you are attending to the lecture through a computer? Computer කරා එන කී දෙනෙක් ඉන්නවද? ෆෝන් එකෙන් එන කවුරුවත් ඉන්නවද නැත්නම් කම්පියුටර් හරහාද හැමෝම ඉන්නේ?
මම නම් මේ පවර් කට් එකෙන්ද ෆෝන් එකෙන් අද නම් ලොග් වෙලා තියෙනවා.
හරි. අනිත් දරුවෝ ටික
laptop.
right. The reason is I can give you the permission to share the screen. So if you draw it in somewhere, maybe Paint or OneNote or whatever, you can share the answer. මොකද ඒ සර්කිට් එක සාමාන්‍යයෙන් අර වචනෙන් විස්තර කරන්න අමාරුයි. කරන්න පුළුවන්. ඒතකොට ඉතින් කියන්නේ නම් මේ ස්විච් එක මෙහෙමයි කනෙක්ට් කළේ කියලා. හරි. විනාඩි 5ක් දෙන්න. try කරලා බලන්න. සිම්පල්ම කේස් එක පටන් ගමු. මේක අමාරු වැඩියද? පළවෙනි කේස් එක. එක බල්බ් එකයි එක ස්විච් එකයි. ඒ බල්බ් එකෙන් ස්විච් එක on off කරන්න, බල්බ් එකෙන් ස්විච් එක on off කරන්න නෙමෙයි. ස්විච් එකෙන් බල්බ් එක on off කරන්න සර්කිට් එකක් හදන්න, right? First part of the question, you have a single bulb like this one and a single switch. Make it such a way that you can switch it on and off using that single switch. That should be very, very easy. Second one, you have two switches. You should be able to switch on the bulb using any of these switches. දෙවෙනි කේස් එකේ ස්විච් දෙකක් තියෙනවා, දෙකෙන් කොයිකෙන් හරි on කරන්න පුළුවන් වෙන්න ඕනේ. කොයික දැම්මත් on වෙන්න ඕනේ. off කරන එක දෙකම off කරන්න වෙනවා. එකක් හරි දැම්මොත් ස්විච් එකෙන් bulb එක on වෙන්න ඕනේ. තුන්වෙනි කේස් එක ඔය මම දැන් කිව්ව එක. third case is the one that I described. You have a single bulb, two switches. you should be able to switch on and off the bulb using any of them. එක බල්බ් එකයි ස්විච් දෙකයි බල්බ් එක ওই ස්විච් දෙකෙන් කොයිකෙන් උනත් on කරන්නයි off කරන්නයි පුළුවන්කම තියෙන්න ඕනේ. හරි. පළවෙනි එක කළා share කරන්න, දෙවෙනි එකත් කළා share කරන්න, තුන්වෙනි එකත් කළා share කරන්න. විනාඩි 5ක් දෙන්න. දැන් 2:04යි. 2:09 වෙනකොට ඉවර කරලා තියන්න. ඒ අතරේ කවුරු හරි ඉවර කළොත් share කරන්න පුළුවන්, right? If anybody finish before that, you can share it. I have given you the sharing permission. And if you have any question, that again you can ask during that time as well. හරිද? ප්‍රශ්නේ පැහැදිලිද? Is the question clear to everyone?
The second instance එක මොකක්ද?
Second instance එක මෙහෙම එකක්. අපි හිතමු මෙතන ගයක් තියෙනවා. මෙතන තියෙනවා ආරක්ෂාර්ථව බල්බ් එකක්. මෙතන ස්විච් දෙකක් තියෙනවා. දැන් මෙතන කවුරු හරි හොරෙක් ඉන්නවා කියලා හිතුනොත් මේ ස්විච් එක මේ කාමරේ කෙනාට ස්විච් එක ඔන් කළත් මේක බලන්න පුළුවන් වෙන්න ඕනේ. මෙයා ඔන් කළත් මේක බලන්න පුළුවන් වෙන්න ඕනේ. මෙයා ඔන් කරපු එක මෙයාට ඔෆ් කරන්න බෑ. දෙන්නකින් කවුරු හරි ඔන් කළොත් මේ ලයිට් එක පත්තු වෙන්න ඕනේ. පැහැදිලිද හරිනේ?
හරි.
ඒ කියන්නේ මෙයා ඔන් කළත් බල්බ් එක ඔන් වෙනවා, මෙයා ඔන් කළත් බල්බ් එක ඔන් වෙනවා. ඕෆ් වෙන්න නම් දෙන්නම ඕෆ් කරලා තියෙන්න ඕනේ. Keithanek, how many of you have finished? Let's look at the first one. We'll ask who? Sama. Did you finish the first one?
Yes, sir, but it's not clear. Can I share it?
Yes, you can share. You have the sharing permission. Okay. Is it the first one or the second one? Okay, we'll say that we can use standard symbols, right? Then you need to have battery or something, right? Battery or supply or something. Where are you going to put that one? Battery hari මොකක් හරි ඔකට දාන්න වෙනවනේ. හිතන්න 230 නෙමෙයි දැන් මේ 12 volt හරි මොකක් හරි එකක් කියලා. 230 වත් ප්‍රශ්නයක් නැහැ. හැබැයි එහෙමනම් අර 230 in කියලා වයර් දෙකක් තියන්න වෙනවා live wire එකට.
Or somewhere here?
Yeah, you can draw it on top.
Like this?
Right. So are these switches SPDT? You can write.
Yes, sir.
Okay. So the question I asked is, even one of the person switch on the bulb should switch on.
Yes, sir. If this was switched off and connect like this,
Okay,
it
then
will
the
be
bulb
switched off.
Okay. Let's say the second person want to switch on the bulb. Some ඔය පළවෙනි question එක දෙවෙනි එක තුන්වෙනි එක දා කරන්නේ.
So the staircase one.
You are doing the staircase one.
Yes.
The hardest one. Okay. Then you have a little issue, right? Let's say now this is switched off, right?
Yes.
Someone comes from the bottom of the stairs. He want to switch on the light.
Oh, there should be another connection coming from.
I don't know. We'll ask someone else until you try on that one. Marsha, what about how the Naivera Karakuri?
ප්‍රසාද් සර් මම ෂෙයා කරන්න මම දන්නේ ෆොටෝ එකක් මේ
Photo එකක් ගහුවද?
ෆොටෝ එකක් ගහුවගෙන මම මේ මොබයිල් එකෙන් ලොග් වෙලා ඉන්නේ
කොලේක ඇදලා ෆොටෝ එකක් ගහුවා. හරි. ඔයාගේ තියෙන සාමගිකේ අනිත් ප්‍රශ්නේ. හිතන්න ඔන්න දැන් එක්කෙනෙක් යට එකකින් on කළා. Right? Someone at the bottom of the stairs switch on the bulb. Now he is at the top. He want to switch it off. How is he going to switch it off? Well, staircase එකකද ඊට කලින් එකද?
ස්ටේර්කේස්
ඊට කලින් එකට නම් ඔක හරියනවා. ඊට කලින් එකේදී switch දෙකෙන් මොකක් හරි on කළොත් on වෙන්න ඕනේනේ. Right? Let's say someone switch on the one of these switches, then the bulb switches on. Then he's at the other side of the staircase. He want to switch it off. එතකොට off කරන්නේ කොහොමද? ආයි පල්ලෙහාට බහලා off කරලා යවුඩ නගින්න බැහැ.
ඔව්
ටිකක් හිතන්න. Think a little bit. Where are we? Was Harini? Pathum, what about you? Pathum, ඉස්සරහ කහන්න බැරි වුණා.
Okay sir, දෙක තුන පොඩ්ඩක් share කරන්න sir.
ඔව් කමක් නැහැ ෂෙයා කරන්න. පැතුම් ඔයාද නුවර ඉන්නවා කිව්වේ?
නෑ sir මම කොළඹ ඉන්නේ.
කොළඹ නුවර ඉන්නේ කවුද එතකොට?
Sir, I'm from Kandy.
You are from Kandy. Okay. Right. Did you have the lectures in the morning?
Not today, sir.
Not today. Oh, have you done this question before? කලින් කරලා තියෙනවද? නේද කලින් තිබ්බ එක පෙන්නන්න 3 එක මම හිතන්නේ හරි වාගේ. මම දැක්ක විදිහට. ඒක හරි. ඔයා කලින් කරලා තිබ්බද මේක? පැතුම් නේද මේ ෂෙයා කරන්නේ? කවුද ෂෙයා කරන්නේ? පැතුම්ද? Who is sharing? Is it පැතුම්? මේ ෂෙයා කරන දරුවා කවුද? පැතුම්ද මාර්ෂාද සාමද ප්‍රසාද කවුද මේ? ඔයාලා බැරිද කවුද ෂෙයා කරන්නේ?
සර් පැතුම්.
පැතුම්. පැතුම් මම මේ කලින් කරලා තිබ්බද පුතේ? Have you done this question before?
එනල්ලාද සර්
ඒක තමයි. Anyway, now you have done it correctly. Now the first two, I believe everyone will be able to handle it. The first part and second part is very straightforward. Third one is that's little bit tricky part, and one person had finished it. Now what to do? We'll ask others to do an extended version, right? එකදරුව කළානේ දැන් උත්තරේ දැක්කනේ. අපි අනිත් අයන්ට ටිකක් දිග එකක් දෙමු. ඊට වඩා වෙනස් එකක්. So here's the extended version as for your homework. Now this one is having only 2 switches, right? Let's say you have a corridor, long corridor. In the middle you have a bulb. But now you want to have, let's say, 4 switches. Now using any of these 4 switches, you should be able to switch this bulb on or off. If you find the pattern, you know how to extend it up to any number. Even if you have 100 switches, n number of switches, you can do it. But for 100 switches, I don't want. I want you to think of a way to have it on and off for 4 switches. Just like in the staircase scenario. Using any of these switches, you should be able to on or off this bulb. This might switch it on, then the same switch you can switch it off, or you can switch it on from here and off it from here, or on it from here and off it from here. Okay. I can give you a little help. You might need to use DP-DT or SP-DT switches. Right? So that part I will leave as a home exercise. Right? Try it when you are free. So that is about switches. Now we will move to a different section. Right? We will look into a different section. Anything you want to ask from switches? Oh, while we are at it, I forgot to tell you another thing. When you are using a switch, it's better to finish it while we are at it rather than going for that one. When you are doing switches, there are 2 practical issues you might face. One thing is called the debouncing. What do you know about debounce? What do you call a debounce? Switch එක debounce වෙනවා කියන්නේ මොකද්ද? කවුරුත් අහලා තියෙනවද? Yes, no, අහලා නැහැ, දැකලා නැහැ. අදම යහුවේ. කොහොම බෑ ටිකක් දැන් උත්තර දෙන්න ඕනේ. නැත්නම් මට කම්මැලි.
ඒ කියන්නේ දෙක on කරත් on වෙනවා off කරත් off වෙනවා on වෙලා තියෙනවා වගේ එකක්.
නෑ එහෙම එකක් නෙමෙයි මෙන්න මේ වගේ. at that end. Right. Now think you have a switch here. In ideal case, when you switch it
We
on,
can't see.
you will have an ideal transition like this.
We can't see.
ස්ක්‍රීන් එක ෂෙයා වෙන්න.
එහෙම මම ඒක ලියලා තියෙන එක. So this is the one that I want for you to explain. I wanted you to explain. This will explain what the debounce is. Now let's say you have a switch like this. In ideal case, when you switch it on and off, you will have a very sharp step like this. On to off, very crisp transition. Unfortunately, these switches are mechanical switches. So there will be some small vibration when you are switching it on and off. Sometimes you get just almost touching and almost not touching situations. So during that brief moment, now this is a very brief moment, not in seconds, probably in several milliseconds. The switch is just touching and touching and losing the contact, kind of vibrating. So you end up with some fluctuations like this before you latch onto the final output. For slow circuits, this won't be a problem. They won't be able to respond to very fast transition like this. But if you're using a digital electronic circuit, it might detect these as switch ons and offs. Let's say you have a counter. Now you're at a hospital. You're at a hospital when a doctor makes an appointment, there's a counter at the top of the doctor's room. Right? So each time a patient goes into the room, this count is incremented by 1, right? Now they increment it by pushing a push button. Each time you go into this room, they use a push button. Now debounce can happen to push button as well. They push it once and the number increments by 1. But if you have fluctuations like this, you might press it once and think it will increase by 1. But unfortunately, it starts vibrating for a certain extent and you might end up with incrementing it by 5 or 6 or something like that. So that is not a desired behavior, right? So we need to reduce it. So that's a practical issue when you are using switches. So how can we reduce it? There are 2 different ways. One is if you're using a software, let's say some microcontroller, then you can write a small code asking it to not to change the status rapidly. For example, you can say once the input changes, wait for, let's say, 5 milliseconds. Before that pin becomes enabled again, something like that. So that way, once it reaches this particular state and identified as a change of state, it will ignore this whatever comes after that for a particular period. So that during that period, the microcontroller will effectively ignore whatever the fluctuations happen. That's a software kind of thing. Or you can use a hardware kind of thing. This one, the simplest way. You can use a capacitor in parallel with the switch. You can use a capacitor in parallel with the switch. In that case, whatever these fluctuations will ground it through this capacitor because it acts as a filter. So whatever these fluctuations will go through this one and ground it. But once the capacitor reaches that particular voltage, it will maintain it. So debouncing will, this noise will get cancelled out. But remember, if you're using something like this, it will delay the input to a certain amount. So if you need something that is fully automatic and need very fast switching, you have to come up with a different scenario. For example, using a latch. But the simplest way for most of the time would be to use a capacitor like this. That is the first thing I want you to consider when you are designing a practical circuit. Now remember these things, because when you are doing the mini project, you will face these things. Second one is something that most people tend to forget. Let's say you have some logic circuit here, and you want to have a counter like I mentioned. So you have a 5 volt and you have a switch. So you expect 0 or 5 volt for here. Let's say 0 or 1 logics for this one. And you have a switch like this. Do you see any issues with this implementation? මේ වගේ සර්කිට් එක ප්‍රශ්න මොකුත් තේරෙනවද? දැන් ගොඩාක් වෙලාවට කට්ටිය මෙහෙම කරනවා. කෙලින්ම ලොජික් ඉන්පුට් එකක් මෙහෙම දානවා, අප් කරගන්න ඕන නම් 5 එකට කනෙක්ට් කරන්න කියලා මෙහෙම දානවා. මේකේ මොකුත් තේරෙන ප්‍රශ්නයක් මොකුත් උකරන්න තියෙනවා. Harini, what about you?
If a large current comes in, then circuit would.
Okay, then we'll put a resistor. That's one issue. That was not the one I'm wondering, but anyway, okay, we'll put a resistor there. Now current is limited. Anything else?
Switch should come after the logic gate.
Sorry?
Switch should come after the logic.
Let's say something like this. Same scenario. You are asked to design a counter for that patient appointment system. You have your display. Let's say large LED display, it displays the number. Then you have your counter circuit. It somehow controls this one. And you have your input. So what this counter does is, each time it receives a pulse like this, it will increment the count by 1 and will show it in the display. Right? And since you asked for a resistor, we put the resistor as well for the safety. And you have, let's say, a push button or a switch. Like this. If you want, you can have a push button as well, connected to 5 volt. Let's put the push button. So what you expect is, okay, we'll put a debouncing part as well. What you expect is, each time you push this one, the number will increment by 1. But there's a small problem with this particular scenario. To be precise, this part has a particular problem. Can you think what the problem might be? මේක මොකක්ද කියලා කාටවත් හිතන්න පුළුවන්. පොඩි දවවක් කරන්න පුළුවන් මේ අනිත් සර්කිට් එක බලන්න. Now, 2 other circuits that I have used to explain the debouncing, they have corrected this problem. Can you find what the problem is? ප්‍රශ්නේ මොකක්ද කියලා හොයාගන්න පුළුවන්. ඒක දැක්කහම පුළුවන් වෙන්න ඕනේ හොයාගන්න.
Ground එක
ground එකට click කරන්න ඕන සර්.
ground එකට එකක් check කරන්න ඕනේද? කවුද ඒ කතාව කිව්වේ? ප්‍රසාද් පැතුම්ද?
ප්‍රසාද්.
හරි. ප්‍රසාද් ground එක connect කරනවා කියමුකෝ. කොතනද ground එකට connect කරන්නේ? කොහොමද connect කරන්නේ? දැනට මේ debouncing කැල්ල අපි අමතක කරමු. ඒකත් තියෙන්න ඕනේ. නමුත් දැන් මේ circuit එක දැනටත් complicated නේ. මේක නෑ කියමු cap එක. ඒකත් පස්සේ දානවා. කොතනද ground එක connect කරන්නේ? දැන් දෙක තුනක් තියෙනවා. A කියලා තේන්න පුළුවන්, B කියලා ගන්න පුළුවන්. ඔන්න C කියලා ගන්නත් පුළුවන්. කොයි point එකට ground එකට connect කරන්න. Which point are we going to connect to the ground? And why?
B.
B. Okay, good. If I connect it like this, will it work? මෙහෙම ground එකට connect කරොත් වැඩ කරයිද?
So instead of this, we can use SPDT switch, and one end is connected to the ground and the other one is connected to the 5 volts.
Yes, that's another possible valid choice. You can have one going for the 5 volt, one going for the ground. Yes, that's a valid solution. But let's say I want to keep a push button because this is a little bit expensive, and you rarely have this kind. No, you have this kind of push button sometimes, but usually this comes in a different form factor, right? Push button in a angle ඔබන්න පුළුවන් මේ SPDT type ගොඩක් ඒවා ටිකක් එක්ක toggle type නැත්තම් ඒ කියන්නේ ඒක එහා මෙහා කරන ලේසියෙන් බෑ. එහාට දැම්මොත් අනිත් පැත්තට ගන්න වෙනවා ආයි මහන්සි වෙලා. හරිනේ, ඒ කියන්නේ මම කිව්ව විදිහට තේරුණාද? ඒකේ physical fact එක පොඩ්ඩක් වෙනස් push button එකේ SPDT එක. ඒ කියන්නේ push button එකේ ඔබලා අතාරින්න විතරයි තියෙන්නේ.
Oh.
SPDT එකක් දැම්මොත් ඉලෙක්ට්‍රිකයි කියන වැඩේ වෙනවා. හැබැයි එතකොට නර්ස්ට උඩට දාලා ආයි පල්ලෙහාටත් දාලා ඉන්න වෙනවා ඊළඟ patient ගන්න කලින්.
Yes.
Right? Now imagine the same scenario for a remote controller. You want to change the volume, you have to push it to up and then down. So if you want to do it 5 times, you have to do up and down 10 times. So in ergonomically, it's not going to work. So I want to keep the push button and come up with a different solution. Electrically වකිව කතාව හරි, electronic පැත්තෙන් ගත්තොත් හරි. Practically හැබැයි circuit එක හදද්දී පොඩි practical පැත්තෙන් මම කැමති push button එක තියාගන්න.
So ඔතන මේ pull down resistant එකක් දාන්න.
අන්න හරි. ප්‍රසාද කිව්වේ. දැන් පැතුම්ද?
පැතුම්.
පැතුම් හරියටම හරි පිටතටම හරි. මෙතනට දාන්න ඕනේ pull down resistor. We have to put a pull down resistor here. Where is that? We have to put a pull down resistor. You have found the word as well. This is called a pull down. Why? You can't have floating things in digital world. Even in analog worlds, that is not accepted at all. Right? Now, some people have a wrong feeling that if something is not connected, it will automatically become 0 volt. That is not the case. Let's say you have something like this, not connected to everything. And inside here, you have very high impedance, let's say FET or something, connected like this, doing something. So that means there's almost 0 current. Some people think this will automatically become 0 volts. That's not correct. We can't define the voltage at here, because there's no current. Whatever the last charge what you had here will be there. It can be 2 volts, 5 volts, 3 volts, or even some electromagnetic fluctuations can affect it, because this is floating. So if you want to have a proper way of, if you want to have a proper control over this scenario, you must make sure every time the voltage is well defined. Every time the voltage is well defined. That is how we do it. That is why we do something like this. So you have to push button and you connect the 5 volt line. Now when the button is pressed, this line is connected. So all the 5 volt comes up here. No issue. But when the button is released, you have an issue because this one is not connected to anywhere. So it's floating. So you have to pull it down to ground. Now what happens? Let's say this is a very large resistance. There's 0 current going in here. No current comes from here. So that means there's no, the current going through is almost 0. Right? So the same current the same current has to go through like this, right? So if this is almost zero, current in here is also almost zero. So if you use Ohm's law, if I is zero, that means the voltage across this terminal also becomes zero. So the voltage across these two terminals is also zero. Voltage difference. This point is grounded. That means this one has 0 volt. This has a difference of 0. So that means this point is also 0 volts. So by using a pull down resistor, we are able to make sure when the switch is not open, the voltage at here is 0. It's no longer floating. Whatever the charge that is left will be grounded through this line, and this will become 0 volts. Now what will happen if I switch it on? When I switch it on, you will notice there's very small resistance across this line. Only the resistance of this particular switch. So that means R is almost 0. Voltage here is 5 volt. Now there will be a small current flowing through this particular pull down resistor. So voltage here will automatically become 5 volts. There will be a small current pulling down from this resistor. But that's a small price to pay comparing the stability you will get. So whenever you have a input, especially when you have a switch, you have to make sure it is in a well-defined state. There are two different ways you can do it. Either you can have pull up resistor like this. Now this is called a pull up, because this voltage is, sorry, the input should be from here. Because when the switch is open, this resistor will try to pull the voltage up, and when the switch is closed, it will drop to 0. Or you have the opposite way. You have the switch or whatever here. You have the pull down resistor. Right? So those two types of resistors are very important. You can usually use something like 10 kilo ohm or 1 mega ohm to do these things, 10K or 100K or whatever. The value is not very crucial, but don't use things like 100 ohm, 200 ohm, things like that. Use something in 10 kilo ohm range, and don't use things like 10 mega or something. That will be too much. Anything around 10, 100, 1 mega will work. So when you are designing a project, when you have switches, make sure you follow this one. Otherwise, you will face into certain logical problems that you will never be able to identify, because your circuit start behaving so illogically. Sometimes without the pull up, if you have another circuit wire going very close to here, this voltage might affect this voltage. So from time to time, it starts working completely random ways. Right? So that's something I wanted you to tell before winding up this session about switches. Right. So that's why you have this in here, you see, in this circuit, you have pull-up circuit here and the debound circuit here. Here also you have the pull-up resistor. So you need to have them in your circuit design. Okay. So I mentioned we are looking at different types of blocks. So we learned one type of sensor today, that is the switch. There are other switcher types, but We'll, for the time being, we'll finish it for today. And now we will look at one of the processing units. One of the processing units, something that you are very familiar with. This one. Can you remember the op-amps? Op-amp එක මතකද?
Yes.
Okay. So what are the mathematical operations that can be implemented using an op-amp? So what are the mathematical operations that can be done using an op-amp?
Addition.
Okay, Harini says addition. Addition. What else?
Integrating.
Sorry?
Integrating. Difference.
Integration.
Integration.
Okay.
Differentiation.
Okay, differentiation. What else?
Differential.
Differential. Are you referring to differentiation or something else?
Differential amplifiers.
Differential amplifier is a circuit design. No, I'm asking about mathematical operations. Yeah, you can say difference rather than saying. So this is similar to subtraction. So you are in a differential amplifier, you are basically taking the difference between two voltages. Anything else you know? Anything else that you know? Okay, there are other things as well. For example, you can use an op-amp for function inversion. And you can use it to comparisons, compare two voltages. You can also use it with a small change to find minimum or maximum values. You can see there are a lot of mathematical operations that can be accomplished using op-amp. That's why it's called op-amp. Op means operational amplifier. So it's important to know these things, because in certain cases, when you're designing a circuit, you need to do these things. Maybe you have two signals, you want to add them. Let's say you are creating an electronic scale to weight something. So you have 4 load cells. You need to add the weights of all these 4 load cells to get the final reading. Then you need to do the addition. Or maybe you are designing some kind of a warning system. You have a sensor. And if the sensor value goes above certain voltage, you have to sound an alarm. Then you need to compare this the sensor value with some predefined voltage level. And if it is high, you have to output a particular value. Or maybe you are doing some kind of filtering. Right? Let's say, what kind of things? You are trying to calculate the total power absorbed by a particular circuit. You want to design a meter. You want to show the total energy absorbed by a particular circuit. Then you have to add all the power consumed during that particular period. So it will be an integration. So like that, there are so many applications. So learning this particular block is very important. So now let's learn about op-amps. Now you have already covered most of the things in the op-amps, so I'm not going into very basic details. Let's start with something like this. What are the main terminals in op-amp? Op-amp එක සාමාන්‍යයෙන් තියෙන pin මොනවද?
Inverting input, non-inverting input, output,
Okay. Right.
then supply voltage.
Yes. So which pin is the inverting input?
2.
Marsha, inverting input එක කොයි එකද? Marsha, ඉන්නවද? Marsha නෑ වගේ. අපි හමු පැතුම්ගේ. පැතුම් inverting input එක කොයි එකද? Aද Bද Cද?
A.
Make inverting input, right? So this is inverting. Plus means the non-inverting. C is the output. In addition, now if you are designing it in most circuit simulation or symbols, or if you are drawing just a circuit schematic, you can get away with this one. You usually don't need to put the power supply pin because that doesn't actually process any information, right? In electronics, we work with processing information. So some kind of voltage signal will come from here, another signal will come from here, different signal will go out from here. The power supply pins are just there to help this component work. But when you are really using the component, you have to connect the power pins. Otherwise, it will not work. Right? Without the power, it will not work. So optionally, sometimes you show this, not plus, let's say plus VCC and minus VCC terminals. And there's another 2 pins that sometimes we use. Prasad, do you know there are 2 more pins usually in op-amps?
So මේ සමහර ඉන්වර්ටින් එකයි නන් මේ අවුට්පුට් එකයි කනෙක්ට් කරලා තියෙනවා අර
නෑ ඒක නෑ op-amp එකකින් එළියට එන තා පින් දෙකක් තියෙන සමහර ඒවා පාවිච්චි වෙන එකක්.
Offset nut.
Offset null, right? That is for the calibrations most of the time. You should have some optional circuit like this called offset null. This is not compulsory. This is only there if you want a very fine behavior of the op-amp. If it's like a calibration, center point adjustment, right? If you want to make sure the output is 0 when both of them are exactly 0, then you can use the offset null. But the things in the orange are not essential. In your circuit design, they are not essential. Usually you can get away with the rest of the things. Right. Now I'm going to ask you a question. What are the golden rules of the op-amp? Okay, writing it in gold is not going to work. What are the golden rules in op-amp?
Voltage difference between inverting and non-inverting inputs is 0.
Okay, that means invert. Okay, let's call it as the inverting. It's almost equal to V non-inverting. Second one. There's a second golden rule. I think Sama said it in the, yeah, what you said is correct. Usually we start with the other one. What you said is the second golden rule. Doesn't matter, the order is not that important, but usually it's the other way around. So what's the remaining one?
No current drawn by the input terminals.
Yes. The current flowing into the input is 0. Whether it can be inverting or non-inverting, current will almost be 0. Do everyone know about these two golden rules? Now remember, this is a lecture, so I'm just speaking to you. If there are any things that not familiar to you or you do not understand, please take a note. I will upload the video, but the best way to learn is to take your own notes. And I'm going a little bit slowly, so you should be able to take down whatever things that is required. Do everyone agree on these two golden rules?
So මේ power cut එකකින් ඉඳන් so මේ battery low වෙලා තියෙන තව ටිකකින් මම මේ leave වෙනවා.
කමක් නැහැ ප්‍රශ්නයක් නැහැ. Anyone have any other suggestions about these things? Right, this one, okay. Input doesn't draw any current or emit any current, or it's almost negligible. But this one is only partially correct. I know this is what you learn when you are doing your A levels, but this is, how can I put it? Not exactly correct. Or we can say it's valid only under certain conditions. That would be a better way. It is only valid under certain conditions. For example, let me ask you this. Now I have an op-amp. Let's connect a 3-volt battery here. And another battery here. Let's say 6 volt. Now, what will be the voltage difference between the inverting and non-inverting inputs? Or we'll forget about this ground pin. We don't need that one as well. We just connect it like this. 6 volts. Battery across the two terminals. Now, what will be the difference voltages between the inverting and non-inverting inputs? හිතන්න බලන්න.
6 volt.
Sorry?
6 volt.
6 volts. If there's no current going into it, this will have 6 volt here, this will have 0 volts, assuming this is reference to ground. So the delta V will be 6 volts. Then what happened to this one? The correct way or a better way to say it is, when you have a closed loop op amp, when you have closed circuit in op amp, the output always try to equalize the inverting and non-inverting inputs. That means instead of saying, I'm saying there are several new words in a closed loop arrangement. That's the first thing. This particular thing happen only in the closed loop arrangement. Then output tries to equalize the inverting and the non-inverting. That means output tries to make certain changes such that the difference between the voltage between the inputs is small. So there are some new words here now. There's something called closed loop, output, equalize V in and V non-inverting means it means they are basically the delta V should be 0. So this is not happening always. For this to happen, it needs to be a closed loop, and even then it is not guaranteed because it says tries. So it may work or may not work. So there are certain limitations. In your A levels or even in level 4 when I'm teaching, we were considering only that particular scenario under those limitations. So that's why we start by making this particular assumption, but it's not the broader truth. So we'll understand this further when it comes to the characteristics, right? Now we have learned the two golden rules. Now I'm going to introduce you another term. Open loop gain. What is this? What do you mean by open loop gain? We'll ask Sama. Sama, what is an open loop gain of an op amp? What does it mean to you? Okay, she may not be there. We'll ask who's there? Marsha, are you back? Marsha seems to be missing also. Maybe there's a power cut. Yes, only Pathum is there. Pathum, what about you?
V out divided by V in.
That means voltage gain. V out divided by V in. This is a general expression for the voltage gain. In fact, the same thing can be said for other things. For example, output current divided by input current. This will be known as the current gain. Similarly, if you change it to power, this will be known as the power gain. So V in divided by, V out divided by V in is a general expression for the voltage gain. We have a much more precise definition for open loop gain. Yeah, you can say open loop voltage gain if you want, but usually we just say open loop gain because in op amps we expect to amplify the voltage.
Gain without the feedback.
Yes, gain without the feedback. So we open loop means closed loop means there's something going back, closing the loop. Open loop means there's nothing going back, it's open. So open loop means there's no connection between the inputs and the outputs. If there's no connection, that is known as open loop configuration. Right? We have inverting and non-inverting and the output. So open loop gain means the voltage gain. That part is correct. When there is no feedback connection, when the circuit is open. Okay. So what is the, we usually write it as AV. What is the equation for this? Or you might prefer to write it as other way around. Usually write it as V out is equal to open loop voltage gain minus V minus. So this is the voltage difference between the two terminals. Okay. This is the open loop voltage gain. So when you don't have any feedback circuit, this equation will give you the, what happened there? When you don't have any feedback circuit, this particular equation will give you the output voltage. Okay. So here's a simple calculation for you to do. Let's say open volt gain of a particular op amp is 1000. V plus is 2 millivolt. V minus is 2.1 millivolt. If it is an open loop circuit, calculate V out. So what will be the output? Can you quickly calculate it? What will be the value? Can you put it into the chat?
4.1 volts.
Very good. That's straightforward, right? Now I'm going to make a change. Let's say this is not millivolts. Let's say this is volt, 2.1 volt and 2 volts. Now what will be the output? By the way, there is a minus sign, okay? Sama, I think you forgot the minus sign.
Yes, sir.
Harini, are you sure about your second answer?
No, sir.
The pattern says it's minus supply voltage. We'll look at the others as well. Sama, what about you? Are you still attempting the question? Sama, are you there?
Yes, sir. So, this so does A means the supply voltage?
No, no,
In-
AV means the open voltage gain. Usually we use the word A for gain.
So it's 100 voltage.
Very good, 100 volts. Harini, what about you?
It should be minus supply voltage.
Yeah, we'll see. Now, if we directly apply this particular equation, we will end up with something like this. Then we know this is 1000. This is 2. This is minus 2.1. So you end up with 100 minus 100. Now, theoretically, this is correct, but practically you have an issue. As the Pathun pointed out, let's say you have this particular op amp powered by, let's say, minus 15 volts to plus 15 volts. Now, op amp cannot generate voltage beyond its supply voltage. Op amp cannot generate voltage higher than or lower than its rail voltage. We call them as rail voltage. In fact, most of the op amps, not most, kind of like a old common op amps like 741, they can't even go to the rail voltage. For example, if you have 15 volts as a plus supply, output might go something like 14 volts or maybe 13.5. It can't even reach the 15 volts. It will saturate before it. Some modern op amps are able to go to the supply voltage level. These are known as rail-to-rail op amps. So if op amp say rail-to-rail, that means its output can reach the supply voltages. But some op amps, you have a voltage drop, just like when you are sending current through a diode, you have 0.7 drop. Similarly, op amps are made from semiconductor devices, so output can drop. Sometimes you will end up with a smaller voltage. So it is clear you will not be able to get minus 100 volt for this one. Instead, what you end up is with the rail voltage, the minus 15 or whatever is supply voltage. So we can include this knowledge and draw a graph. Right? We can include this knowledge and draw a graph showing this would be the V plus minus V minus. So this will be the input. This will be the V output. So from our previous example, we know this is a linear relationship, right? Y equals mx type of relationship. So you get a straight line. Something like this. However, it will not continue infinitely into the infinity. Instead, at some point, it will reach its saturated value. Let's say the supply voltage is here, plus 15 or something. Then it will start saturating like this. Similarly, this side you will have a minus supply voltage. So you can see at a certain point you have a very linear relationship between input and output. So this is the linear region. These are saturated regions. Right? So if you go above the linear region, you will start saturating. Now, when you are doing calculations in the A levels or in level 4, one thing we usually try to do is we try to make sure your calculations are within this linear period, linear region. So we call it under the linear region. So within that region, you will notice the, okay, I'll give it as a calculation. Now assume the same op amp with the open voltage gain of 1000 and assume the supply voltage is plus 15 to minus 15. If we use this op amp in the open loop configuration, what will be my linear region? That means what will be my inputs? This voltage, where my output will be linear. Can you calculate this one? What will be my input voltage difference for my output to be linear? Can you quickly calculate it? So AV is 1000. Supplies plus 15 and minus 15. What will be the value for this one? So, what about you? I think Harini and Petum had finished. Okay, you have finished as well. Yes, the answer is correct. Minus 15 millivolts to plus 15 millivolts. Since you have got the correct answer, I believe you know the method. You have to make sure the output is equal to or below the supply voltage. So in this case, if you think this is a rail-to-rail op-amp and assuming output is 15 volts, you have to find the input voltage difference that produce 15 volts. The output is 15 volts, gain is 1000. So the input happens to be 15 divided by 1000, 15 millivolts. Now that can be applied to both directions, either for the positive rail or for the negative rail. So the difference can be either plus 15 millivolts or the minus 15 millivolts. Very good. So you can see, although I had drawn it like this, if you drew it to a correct scale, it would be more or less like something like this. Hmm. Okay, let's say this is the scale. Then if you draw it like this, it would be almost like something like this. Very sharp increment. What is this? Hmm. And after that, you will have saturation point where it goes like this. Right? We can see this is very small region, about 30 milliwatt in this case. And as the op-amp gain increases, this range will even, the gain will, as the gain increases, this region will become even more small. So this can be either a good thing or a bad thing. If you want to use the op-amp in a linear region, for example, if you want to amplify a signal like this, something like this, you have to make sure this is within the linear region. Otherwise, you will get saturated after that point. Then you have to make sure the linear region is either large or your signal is comparatively small. But there are certain cases where you can use this functionality as an application, certain advantages. So next I'm going to give you a certain scenario like this. Right? Let's say your friend is designing a circuit. No, your friend wants a circuit. You have to design it. Let's say he has, I don't know, he's manufacturing something at their home. Maybe in this hard time, he's trying to manufacture soap at home. Right? So you have to make sure this, let's say the soap mixture doesn't get about 70 Celsius. Or something like that. If it goes above 70 Celsius, then you have to run an alarm. I haven't touched about temperature sensors so far, but assume you have a thermocouple or something like that. So the function of the thermocouple is it generates a voltage proportional to the temperature. Now for the simplicity, we'll come up with something like this. So this is grounded. When the temperature is 70 Celsius, your thermocouple generate, let's say 2 volts. If it is above 70, your thermocouple voltage will go above 2 volts. If it is below 70 Celsius, your thermocouple voltage will reduce or will be less than 2.0 volts. So this will be your input. And for the alarm, let's say you have some kind of a buzzer circuit, some kind of musical buzzer. When you reach, let's say 12 volts, if you give 12 volts to this buzzer, this will output an alarm. If your supply voltage is less than 12 volt, let's say 2 volt, 3 volt, whatever, then the output will be, there won't be any sound. Now I want you to design a circuit for this particular purpose. I hope you got the scenario. You have a thermocouple which output a voltage proportional to the temperature. Right? So as the voltage increases, as the temperature increases, the voltage also increases. I should have written it in the other way around. So your critical temperature is 70 Celsius. At that critical temperature, the thermocouple output is 2 volts. And your output device is this kind of buzzer. I want you to design a circuit for this. So you have the sensor. That's the thermocouple I mentioned here. You have the buzzer as the output. This here. This is the block I want you to design. It should take the sensor input and produce an output when this particular condition is reached. When the temperature is 70 or above, it should generate an output. Can you quickly do that? It's okay to try new things. You can get wrong, no problem. You can improve things. You can try out different new methods. I want you to just try it. Right? So that's why I said this course is a little bit different than the level 4 one. It's open-ended questions. There can be dozens of ways to design this particular circuit. But I would prefer if you try to do it using the op amps that we have learned so far. Right, give it a try. I'll give you how many? 10 minutes? Okay, I'll give you 10 minutes. පැතුම් කොහොමද ඉවරද? හරිනේ කොහොමද? ඔයගොල්ලෝ ඉවරද? ඔකට තව ඕන component දාන්න පුළුවන්. හොඳයි මට ඒක කියන්න අමතක. If you need you can add other components there as well. Resistors, capacitors, diodes, so whatever you like you can include.
So මාද මොබයිල් එකේ ඉන්නේ power cut එක හොඳ එක පෙන්වන්න විදිය.
ඔයාලා කඩදාසියක අදින්න පුළුවන්. නැත්නම් ෆොටෝ එකක් ගහලා දාමු.
හරි.
තමන් කරා
ෂෙයා කරන්නකෝ ඔයාලා. Okay. බොහොම හොඳයි. අතර ඩයෝඩ් එකක් තියෙන්නේ මොකක්ද? ඔයතුමාගේ ඔක්කොම ටික වගේ හරි. මට මේ ඩයෝඩ් එක තේරෙන්නේ නැහැ. බස් එක ගාව තියෙන ඩයෝඩ් එක මොකක්ද?
එතන සර් මෙයා දැන් non inverting එකේ වැඩි වුණොත් එහෙම output එක +12 වෙනවානේ. ඒ අනිත් පැත්තට කරන්ට් එක යන්නේ නැහැ ඒතකොට.
right. එතනින් ඒක
මොකද output එක -3 විතරයි කර මේ බස් එක වැඩ කරන්නේ.
හරි. ටෙම්පරේචර් ඩ්‍රොප් වුණොත් එමෙ එන ප්‍රශ්න තමයි එතන නවත්තලා තියෙන්නේ.
ඔව්.
එතනොත් එහෙම කරන්නත් පුළුවනි. සාහන නෑ ඒක අතර සර්කිට් එක හරි. තව පොඩි ඉම්ප්‍රූව්මන්ට් ටිකක් කරන්න පුළුවනි. අනිත් දෙන්නගේ මොකද තත්ත්වය? සෙන්සර් එකක් තියෙනවා. ඒ කවුද සාමද?
Yes, sir.
Okay. Sama, in your sensor, I see there's another line connecting to the ground. So what is that one? Oh, යතන තියෙන ඒ ground line එක මොකද්ද?
This one, then, sir.
Yeah, what is that one?
I thought it should be there.
Now sensor has two wires, like a small
Then-
battery, right?
Okay, sir. So then I have to remove this one.
Yeah. So whenever you are drawing something, there should be a purpose for it, right? Next question is, why is the buzzer grounded like that?
Okay, sir.
Now let's say I think you are taking the output from the op amp, right?
So there should be another resistor here, right?
Where
Here as a pull down resistor.
Now remember, pull downs and pull ups are only for switches. Switches mean the sense if you don't want any floating output, floating inputs. For a speaker, you don't need a pull down or pull up.
Okay, so then I have to remove that one also. Right?
Yes, you can just directly connect output into one of the power rails. Depending on how you connect it, it can be either positive rail or the negative rail. Right? Because in the pull up and pull downs are there, because you don't draw any current, but you are sensitive to its voltage. So if you have any charges left, your sensor, your sensing IC, logic IC can detect it as a voltage. We don't want that. We want to make sure it has only 5 volts or 0 volts. So that's the purpose. But if you already have a current output that can drive it, then you don't need to have pull up or pull downs.
Okay, sir.
Sama, can you kindly explain how it works? How your circuit works? For example, what will be the voltage at inverting input? Hello, are you there? I don't know whether your line is disconnected.
Yes, I'm here.
Okay, your circuit is, I think, is almost correct. Can you explain how it works? Hey, it's not hard. You can say, okay, here we have this voltage here, this voltage here. When sensor heat up or cool down, this thing happen, and then this will happen, and then this happen, and therefore the buzzer runs or something like that. Right? So what is, when you are designing something must be in your head, right? That's why you design it like this. You should have some idea, okay, I will take the input like this, then I will do a comparison like this, and if this happens, I will output like this, something like that, right? In your head, you should have something like that, otherwise you won't be able to draw it. So can you briefly explain it? No need to shy, there are only 3 students. First, I think disconnected because of the power issue. Okay, then we'll ask Patum. Patum, can you explain your circuit?
Okay, sir.
Okay, you can share and explain your circuit.
I used potential divider circuit for non-inverting input.
Good.
Then voltage at non-inverting input is always +2.
Mm-hmm.
When temperature is below 70, non-inverting input voltage is below 2.
Mm-hmm.
Then non-inverting voltage greater than the inverting voltage. Then output will be +12. Output +12 and other side 0. Then current doesn't flow to the diode. When temperature rise, potential at inverting input is greater than 2.
Mm-hmm.
That means output will be -12.
Mm-hmm.
Other side 0. Then current pass through the buzzer. And
Good. That's a very good explanation. There are some possible small improvements. Now your circuit is fine, it's working. For example, rather than using a diode, now your circuit has 2 different things. One is you need to have dual power supply for the op-amp, right? Why do we use a dual power supply? Because we want to have the positive output and a negative output, right? Both positive and negative output. That's why we use dual supply. But in your case, you use a dual supply, then use a diode to cut off half of it. Then can someone make a suggestion how to improve that? The reason we are using dual supply is to have a negative voltage. But here we are purposefully cutting it down.
so we can -12 also can ground it. and then buzzer can connect plus 12 and output.
Don't connect -12 to ground because then there will be a short circuit. What you can do is now
And
the way you have connected is I think buzzer sounds only when output is negative, right? -12.
Yes, sir.
That's a little bit not the normal method, but what you can do is then you can remove the +12 voltage. You can have 0 and a -12 as your op-amp supply. Then what will happen is your op-amp output can go up to 0 volts, not above it because your supply doesn't have it. But it can go below it because your supply has -12. You get what I'm saying?
Yes, sir.
In the output characteristic, so far the one I showed you was symmetrical. Both plus and negative, positive supply and the negative supply were equal, +15, -15. But you don't have to do it like that. You can either make it asymmetric or you can even completely ignore one side. Only downside is if you ignore one rail, let's say your op-amp supply 0 volt and +15, your output will also be between 0 and 15 volts. So any negative signal will not be shown. But in this case, we don't want to show negative signal. So you can rearrange your rails, remove one rail and remove the diode as well. That's good. And UA1 and SAMA, I saw another improvement that is possible to do. Harini, what about you? Were you able to draw it on and capture it in an image?
Yes, sir. Shall I share it?
Yes, please. So then we can discuss all the three solutions. Okay, your one is also the similar, quite similar. Only thing is now you have put a pull-up resistor. Okay, no problem. Even without the pull-up, it will work. The reason is the reason to put pull-up is when it is floating. Floating means it is not connected to anything. But here, even without the pull-up, you have it connected to the sensor, so it won't be a big issue. But there's something I like to tell to you all. Now everyone is comparing the voltage with the reference voltage. That is good. That is the correct way. That's the one I expected. But how do you generate that reference voltage? You are using voltage dividers. That is good. No problem. And you have calculated values as well. That's again good. But I see there are two issues, two small issues. One issue is from the Pathum's one, I think Pathum is using two power supplies, one to power up the op-amp, another to just to have the reference voltage. In Harini's one, you are using the same supply, but again you are using two resistors as voltage dividers. So there's a small issue with that thing. Remember now, let's say your supply fluctuates a little bit. Then what will happen to your reference voltage? Let's say your 4 volt increased to, no, because the battery was dead, it decreased to 3 volts. Then what will happen to your reference voltage? Will it remain at 2 volts? Then reference voltage එක දැන් resistor divider එකක් දාලා supply voltage එකක් බෙදලානේ. හිතන්න කොහොමද දැන් supply voltage එක drop වෙනවා. 4 volt තිබ්බ එක battery එක බහලා 3 volt වෙනවා. දැන් reference voltage එක කීයද එන්නේ එතකොට?
1.5.
1.5. Yeah. So that means the reference voltage change with the supply voltage. But there is a component, I didn't cover it in today's lecture, but in like level 4 and in A levels, there is a component that can be used to have a fixed voltage. What is the component? Component එකක් තියෙනවා ඒක දාලා අපිට voltage එක regulate කරන්න පුළුවන්, fix කරගන්න පුළුවන්. Supply voltage එක අඩු වැඩි වුණාට කමක් නැහැ. ඒ voltage එක අපිට අවශ්‍ය voltage එක නවත්තන්න පුළුවන්. මොකක්ද ඒ component එක? හිතන්න පුළුවනිද? බොහොම පොඩි component එකක්. voltage regulation වලට පාවිච්චි කරන එකක්.
Zener diode.
Zener diode, exactly. So if you are including a Zener diode in the diagram, what's going to happen? Pratim, can you share your circuit?
Sorry, sir.
Can you share your circuit? By underbreaker? Calling underbreaker? Right. So Pratham, if you are putting a Zener diode, where are you going to put the Zener diode in this diagram? And what is the value? මේකට සෙන එකක් දානවා කොහෙටද දාන්නේ කීයක එකක් දානවා කියන අපි reference voltage එක හදාගන්න 2 volt ඒක කොහොමද හදන්නේ සෙන diode එකක් දාලා
Zener diode can connect parallel to buzzer.
No, not the buzzer, right? You want to have a fixed voltage for what purpose? අපි දැන් fixed voltage එක ගැන comparison කරන එකක් ගැන කී හිටියේ reference voltage එකක් නේ. ඒතර buzzer side එක අදාළ වෙන්නේ නැහැ. buzzer side එක කියන්නේ output එක.
Sir.
TC කියලා input sense එක. comparison එක කරන කැලේ තමයි අපිට වඩා හොඳ comparison එකක් කරන්න අවශ්‍ය. ඒ කියන්නේ processing unit එක මැද්දේ කැලේ. මැද්දේ කැලේ ඔය තියෙන විදිහට වැඩ කරනවා. නමුත් එච්චරම stable නැහැ. supply දෙකකුත් ඕනේ. ඒ වෙනුවට ඔයාගේ කියනනම් දැන් non inverting input එකට fixed 2 volts දෙන ක්‍රමයක් තියෙනවද? හරියටම fixed එකක්. අනිත් කාට හරි අදහසක් තියෙනවද සාමා? What about you? Sama or Prasad, how do you connect a Zener diode to get a pre-known fixed voltage?
One K එකට in parallel Zener diode එකක් අපිට connect කරන්න පුළුවන්.
1K දෙකක් තියෙනවනේ. එතනයි ප්‍රශ්නේ. දැන් කොයි 1K එකද?
යට තියෙනවා.
යට තියෙන 1K එකට. බොහොම කිට්ටුයි. තියෙන එකම ප්‍රශ්නේ ඕක parallel දාන්නත් ඕනේද? 1K එක replace කරන්න බැරිද?
ඔය replace කරනවා.
So that's another way you can do. You can replace the 1K resistor at the below with a Zener diode. What should be the voltage? Where should be the anode and cathode? Voltage එක කීයක් වෙන්න ඕනද? anode cathode කොහොමද තියෙන්න ඕන?
2 volts වෙන්න ඕනේ. ඒක invert වෙලා anode එක උඩටයි cathode එක යට.
ඔව් anode එක උඩට cathode එක යටට right. Value
2 volts.
2 volts. Yes, you can put a 2 volt Zener diode as a reference voltage. Then you can connect your 1K resistor at top directly to the plus 12 supply. එහෙම Zener diode එක දැම්මට පස්සේ ආයි 4 volt එකක් ඕනේ කෙලින් plus 12 supply එකට connect කරන්නම පුළුවනි. මොකද supply voltage එක වෙනස් වුණාට අතන voltage එක වෙනස් වෙන්නේ නැහැ. ඒක 2 volt fix වෙලා තියෙනවා. හැබැයි 1K එක සමහර විට පොඩ්ඩක් calculate කරන්න වෙයි Zener diode එකේ voltage එකත් එක්ක ඔරොත්තු දෙයිද කියලා. Right? So that way you can decide a circuit for that. Right, it's almost 4 o'clock. Before finishing for today, I'm going to give you another small homework for you to try. Right. I am going to put the question in the chat so you can copy paste it. Here's the question. Amal wants to switch on a 6 volt lamp inside a room when outside is dark. So he's going to use LDR, okay? LDR has a resistance of 100 kilo ohm when it is dark and 10 kilo ohm when the air is light. Using op-amps, resistors and LDR, design a circuit for this. Second part, how do you improve the above circuit so he can easily change the light intensity level which the lamp is turned on? So that's the scenario. You want to design a circuit that automatically switch on a light when it becomes darker. As the light sensor, so I did not cover the sensors under the sensors. I have not yet covered the LDR, but LDR is basically a resistor that changes its resistance depending on the light. That's why it's called light dependent resistor. So LDR has a resistor of 100 kilo ohms. So it has 100 kilo ohms when it is dark and 10K when it is light. So you have to design a circuit for this particular scenario. And the second part, you have to make it easily adjustable. So we have a knob or something. So you can decide what light intensity should switch on the circuit. I guess it will be very straightforward. So that's your homework. Anything you want to ask about today's lecture? Anything you want to ask from today's content?
So can you show how the DP-DT and DPST works? I didn't get that.
SPDT, DPDT, that thing.
Yeah, only DP-DT. How does that work?
Okay. Are you referring to the actual physical scenario or the electrical connections?
Electrical connection.
Right. So there is a large variety of switches. There's something called pole. Pole is the one that goes up and down. This is the pole. And it connects to what is known as throws. So this is a single pole double throw switch. So we write it as single pole double throw. If you have something like only like this, which call it single pole single throw. And if you have something like this, now that time I only gave you fraction of this is known as double pole single throw. Why? Each switch has only a single throw. The one you are asking is basically something like this. You can think of it as two different two-way switches, but they work simultaneously with each other. So when you connect it to the top one, you get connection like this. And if you connect it to the bottom one, you get a connection like this. So it basically made from something like this. Let's say these are, it usually has 4, you need to have 6 wires. And you have some plastic kind of thing. And there's another connecting conductor, metal sheet or something like this in both of these sides. So this switch can move this side and this side. So when it is at this position, this one and this one is connected. This one and this one is connected. Now let's say you move the switch to the other side. Then what's going to happen is this one and this one is connected, and this one is connected. So by moving the switch here and there, you either connected these two and these two, or you connect these two and these two. So this is actually the center. This is DP-DT. This is the pole, first pole, second pole. This is the throw one, throw 2, throw 1, and throw 2. You will usually find it in a package like this. Something like this. Is it okay? Or do you need some more explanation?
Okay.
So DPDs are quite commonly used, especially if you have a DC motor to switch it in bidirectional. You should use it to change the direction, clockwise and anti-clockwise. We use that one. Anything else?